Okay, let's get going here. It's 6:23. This is video 141. And as I mentioned in the letter this morning, I'm introducing a new concept, I'm going to call it, called rational expressions. And I told you, I mentioned in the letter that I'd skipped a whole chapter and moved on, and because I don't want to get involved in introducing all these new ideas and not being able to back them up. So with rational expressions, at least the parts that we're going to do, we might ignore other parts. It's just practice for what we've learned in the last couple of weeks. That is factoring and finding restrictions and things of that nature. So that's where we'll leave it here, finishing up the year. So I'll start right away. So we talk about a rational expression. Well, expression means it doesn't equal anything, and that's the whole point. We don't want to get into this math when it starts to equal things. That's just another completely different topic. No equations. So what is it? It's one polynomial divided by another. And since you should recall that polynomials are undefined if they have a negative exponent, then this is just not a polynomial. It's two polynomials, one dividing the other. And why do we call it rational? Because I told you polynomials should be looked at basically like numbers. They can be reduced, they can be factored, all these kind of things. And so it would be equivalent to 3 divided by 4, which is rational. A lot of kids say, but what's not rational? Well, consider negative, the square root of 3 divided by 4. Since this is an irrational number, this expression, this numeric expression, is irrational. So that's the general concept of what's going on. And so when you put one polynomial over another polynomial, often it's the case, and that's all we're interested in, is that you can simplify. That is, you can reduce. So for example, just to make the point with numbers, if someone told me 6 is divided by 8, well, that's certainly rational. But we find a number that divides both sides, and we'd end up with 3 over 4. So that's called simplifying or reducing. I often use that word. But we're doing, like I said before, the polynomials, we consider them just like numbers. We treat them as such. It's a new level of math. So here I reduced a fraction and turned it into 3 over 4. It's rational, and now it's simplified. Okay? And I'll give you some examples in a second. And let's go on now to the third topic here. So we talked about rational, irrational. Well, as it turns out, as I told you so many times over the course of the year, is you're not allowed to have a 0 in the denominator in math. Okay? So here, this 0 is called undefined in the math books, and that's where we introduce the idea of a restriction. Okay? So we can come up with any polynomial divided by another polynomial, but it can't equal 0 on the bottom, and you can't have a value inside the polynomials, the numbers that you're using, that give you a 0. And I'll give you some examples on that in the not too distant future. Just give me a couple minutes. So the number that makes something 0 on the bottom of an expression is called the excluded value. So you can use all the other numbers in the universe, but you can't use that. And the idea that it can't equal something, which we'll talk about, is called the restriction. So these two ideas are best seen as I do the math this morning. This is basically what's going on. So there it is. One more time. Rational expressions are just one polynomial divided by another polynomial, with the restriction that the values that you put into the bottom polynomial can't come up with 0 because that's undefined. And they're called rational because there's no radical sign. Everything is treated just like numbers. And to simplify them is to reduce them if possible. Some can be, some can't be. We'll talk about that a little bit when we expand our ideas. And like I said, they're all restrictions, but not necessarily restrictions, as we'll see in the first case. So let me get the work out here. You learn best with examples, I understand that. But it's important to know what the words mean. So you could play that back and make sure that you're really clear what the words mean, and I'm going to write out one polynomial. No, this is a polynomial, a quadratic polynomial, really a quadratic trinomial, and I'm dividing it by a binomial. It's linear, and I'm double checking my numbers to make sure that I didn't make a mistake here. And I'm going to call this step 1, and we look at this, and our objective here, and we'll always be doing the same thing, is to simplify if possible, find restrictions if they exist, and if there's a restriction, okay, whoops, over here again, simplify when possible, find the restrictions if they exist, and if the restriction exists, they want you to state the excluded value or values. So that's all I'm going to do here. Now, before I go deeper into this, to do this problem, I want to make a point here. This is an algebraic expression, x minus 1. If I divide it by the same thing, it cancels. It equals 1. Just like 4 divided by 4 equals 1. Okay? So anything divided by itself, they're just numbers. They follow the rules of numbers, basically, for the most part. And anything divided by itself is going to be 1 in this math as well. So that's what you're looking for when you do your simplification. You're looking to cancel identical polynomials, if you like. Usually they're just binomials. So what can we factor out of this? We go back to this. Well, anybody can see who's been doing the work that the 2 factors out mad easy. So there's n, and there's minus 2. Everybody see that, right? Go backwards, you double check yourself, because the smallest mistake in this math turns out to be a real disaster. You can't, and this kind of math doesn't suffer for tiny mistakes. And there we go. So always check yourself going backwards to make sure you got this factored out. And of course the 2's are going to cancel. I'm going to leave them there just for the time being, but they'll go away. So the real question becomes, can you break this down more? That is, can you factor this this trinomial, this quadratic trinomial? And generally speaking, that's the game. It'll ask you to do that. So what 2 numbers multiply out to -2 and add up to -1? So you're expected to be able to do this at your age, and you'll continue to get practice to do that at your age, and we'll have that done there. So we completely factor that you can do in this case, and in any order, the factors are -2 and 1, and you have n minus 2 times n plus 1. Okay? And now that's the top number. The bottom number can't be factored anymore. After all, it's only first degree. That is, it's linear. And here we go with the ideas. And this is the whole game they want you to play. The 2's cancel because they're separated out by themselves, and anything divided by itself cancels. And the simplified form of this is n plus 1. So this really means this. This simplifies to this, just like 6 over 8 simplified to 3 over 4. And that's the game they want you to play. Now, are there any restrictions here? That's a good question. Well, the answer, no. There's nothing on the bottom. The only number on the bottom, if you insist on putting it, is the 1. So the restrictions in this math refer to what's going on in the denominator, not what's going on in the numerator. So keep that clearly in mind. There are no restrictions here. And if there are no restrictions, how could there be an excluded value? Okay? So I'm going to do a second one here. It's just a logical sequence of what I've been doing before. And again, those are the steps that I used to come up with the answer. And now I'm just erasing this, and I'll get the second one up, lickety-split. And we'll see that this has a slightly different format. And like I said, I'll give you practice. I'll do a couple more on a video later, okay? And let you work on these things, the easy ones. Of course, we're doing the easy ones. But they don't get that bad. They don't get that complicated. So there we go, okay? And we got this in our focus here. We have a binomial linear on the top, and we have a quadratic trinomial on the bottom. They don't equal anything. And can they be simplified? Well, you see the 3 permeates everybody. So there we go. Whoops. Be careful about that. Okay. And again, always work backwards. It's easy enough to make a mistake. We'll call this number 2. And now, on the bottom, I'll just factor out the 3 and then take a closer look at what's left. If anything is going to work for me here, and that would be that, and that would be a 2. Watch what you're doing here. And we see the 3's go away right away, but we suspect that this is going to be factorable as well. Otherwise, why would they give it to us, right? This would be the answer canceling the 3's. So generally speaking, it's like a game. You get the idea working on them for a couple problems. And again, you got to be careful about what you do here. So let's see. 2 numbers that add up to -3, multiply out +2. There really aren't that many choices. And there you go on the side. Have to be able to do this in high school. What do you want me to tell you? You mad at me? I mean, really, you've got to be able to do this. Making sure that I didn't make a mistake here, going back and forth. And now, this turns out to be a little different. The 3's, of course, cancel, and 2x minus 2 has been explained to you. That canceled. But what's left? Well, a common mistake for kids is to think there's a 0 or something like that on the top. There's just 1. 1 times any number is that number. So the 1 didn't go away. It's on the top. Keep that in mind in high school. Everybody canceled except what? Oh, so kid says, okay, there's something on the bottom, has to do something with restrictions if they exist. So I go over here, and I'm going to do it algebraically, find the restriction. This is the restriction, by the way. And then I'm going to find the excluded value. But, so what is the restriction? The restriction is x minus 1 cannot equal 0. That's a definition. Think about what I just wrote. That's the restriction. X minus 1 cannot equal 0. So if I don't see it, which you should, keep the inequality sign there, take the opposite on both sides, and it says x cannot equal what? 1. Well, that's called the excluded value. And that's how the game is played. Okay? So you simplify. If there's something on the bottom, you set up the restriction, which is here. You can do an inequality algebra thing if you like, or I know a lot of kids. And in a problem, you might write out to your teacher in high school something like this. 1 over x minus 1 is the simplification, excuse me, let me get that going, of this, is the simplification of this with the excluded value of 1. You might say it that way in your high school class. So think about what I did. We'll get a little more practice later, and which I'll do a video on, and then I'll give you assignment, and then we'll turn our attention to the Regents book and more difficult problems, but in the same vein. So turn this off.